Okay, Assalamualaikum warahmatullahi wabarakatuh to all students. So in this video, we are going to continue our learning in chapter 5, Network in Graph Theory for Mathematics Form 4 KSSM. Alright, so in this video, we are going to compare and contrast, okay, as stated here in the learning standard. Compare and contrast the directed graphs and undirected graphs, and another one is between weighted graphs and unweighted graphs. So these two are our learning standard in this video. Okay, so the first thing, we are going to compare and contrast, okay, look at the similarities and the differences between directed and undirected graphs. So you can refer textbook page 135. Okay, so the first thing is that we have to know the definition of directed graph. So what is directed graph? Directed graph is actually a graph in which direction is assigned. So the direction is assigned to the edge. Because of that, we call it as directed graph. There is direction assigned to the edge, okay, connecting the two vertices. Okay, and the directed graph usually used to represent a flow of a certain process. Okay, and the examples that we normally use directed graph are road maps, airlines, networks, and then electric circuits, okay, computer networks, and many more. Okay, so the important things in directed graph is that it has direction. So this is an example of directed graph in diagram 1 here, where we can see we have three vertices A, B, and C. So between these three vertices there are edges. Okay, so these edges here, we have arrow which indicates the direction. So for example, this line at the bottom here shows the direction from C to A. Okay, not A going to C, but C going to A. So that is what we call as directed graph. Okay, so let's look at the differences between directed graphs and undirected graph. Okay, as you can see at the top here, this is an example of undirected graph, which means the graph, the edges has no direction. Okay, but below here, which is examples of directed graph, okay, almost similar. The difference is that here at the bottom, we have arrow indicates the directions on all the edges. Okay, so the important things in the difference between directed graphs and undirected graphs is the order of the vertices written. Okay, for undirected graph, the order of the vertices written not important, which means if you write in ordered pairs AB and BA, is actually the same thing. Okay, AB, BA is actually the same thing for undirected graph. But for directed graph, the order of the vertices is very important because it will be written according to the direction, which means if you write BA, means that we have a point from B to A. But if you write AB, means that it is from A going to B. So the direction, the ordered pairs represent different edges. BA and AB are not the same. So that is the main difference between directed graph and undirected graph, which is the order of vertices. Okay, directed graph written according to direction, undirected graph is not important. So either you want to write AB or BA is actually the same thing. Okay, then we look at the next table, which is the degrees. So as we can see here, the sum of degrees for undirected graph and the sum of degrees for directed graph is actually the same. But the difference here is that we have a new things which we can see written here, D in and D out. So what is actually D in and D out? So for directed graphs, the number, okay, the degrees is actually to calculate that the degrees, we have to look at the degrees going in and the degrees going out from the point. Okay, so let's see example here. Alright, as if you can see, I hope all of you can see here. So the first one is D in B, meaning that degree going into B. As we can see here, okay, at the diagram, from point B, actually the edges here shows that the direction from B going to C, going out to C, and B going out to A. So there is no edges or there is no degree coming into, going into point B. Therefore, D in B is equal to 0. But D out B is equal to 2 because we have B going out to C and B going out to A. Okay, so let's see another example to make us understand better. Okay, D in C is equal to 2. Meaning from point C, we have 2 degree going into, which is from D to C, 1, and from B to C. So we have 2. But D out C, there is only 1, which is from C going out to A. So in order to know D in and D out, we have to make sure and identify the directions of the edges. Okay, so that's important things in directed graph. Look at the arrow to determine the directions of the edges. Okay, so now let's look at the difference between weighted and unweighted graphs. So here, the table, you can refer to the textbook in page 137. What are the difference between weighted and unweighted graph? So weighted graph and unweighted graph both can be represented by directed graph or undirected graph. Okay, no problem. The difference is here, which is we have weighted graph associated with a value or weight, but unweighted graph not associated with any values or weight. Okay, and the examples in using weighted graph, as you can see here, either we use in distance, traveling time, current for electric circuit, and the cost. And unweighted graph, also there is a lot of applications using unweighted graph, which is in job hierarchy, floor map, tree map, bubble map, and many more. Okay, this is just some of the examples. So we can see here. So here is the examples of weighted graph. Okay, as you can see, each edges in this diagram, there is value. Okay, value associated for each edges. Okay, so these values here represent the distance from point V1 to V2. The distance is 600 meter. From V2 to V5 is 500 meter, and so on. So this is an examples of weighted graph. Alright, so now let's look at examples, okay, on how to draw a directed graph based on the given information. Alright, so just like we already learned before in drawing any graph, the first thing is that we determine the vertices, and then we just draw randomly the vertices. So we have P, Q, R, S, T, U. So randomly plotted the vertices. And then the important things in drawing directed graph is that the direction. Okay, must remember the direction is very important in directed graphs. So if it is written here PQ, meaning you have to draw an arrow from P going to Q. That's it. Okay, and then QR means from Q going to R. So QR. QS, Q going to S. SP, S going to P. Okay, so the arrow here is very important. Don't do any mistakes on the arrow, because once the arrow is different, that means the edges are different. Okay, SP and PS are not the same. Okay, and then we continue SR, ST, and the last one UT. Okay, so this is an answer for this example. And again, this is not the only shapes for the graph for this question. Right. So examples, another examples for the answer. Okay, as long as you write down the correct vertices with the correct edges, with the correct arrows and direction, then you get full marks for drawing directed graph. Okay, so now draw directed graph, but the given information is about the degree going into and degree going out from the vertices. So we have here P, Q, R, S are the vertices. So draw the vertices P, Q, R, S randomly. And then my tips for this kind of question is that we start with the least one. Okay, so for example, here we have D in P is equal to 0, D out P is equal to 2, D in Q is equal to 4, D out Q is equal to 2, and so on. So as we can see here, the least one should be D in P and D out P, 0 and 2. Instead of we start with Q or S, better we start with P or R. Okay, so in the question here, D in P is 0, meaning there is no edges going into P. No edges going into P. D out P is equal to 2, meaning we want 2 edges going out from P. So I would like to do P going to Q, P going to S. Why I didn't do P going to R? Because the point here, D in for R is 0. So for point R, there is also no edges coming into. So I cannot do PR. Okay, I just can do P going to Q and P going to S. Alright, and then same goes to R. D in is 0, D out is 2. So R going to Q and R going to S. RS and RQ. I didn't do RP because D in for P is 0. Okay, so once we have settled with the least one, okay, and then we go to the next level. So we only have point Q and S in this example. So both point Q and S, as you can see, the degree going into and degree going out of point Q and S are exactly the same. So as you can see now, for point S, there are already 2 degree in. For point Q also 2 degree in. So we need another 2 degree in for both vertices. Okay, so that means I have to do Q going to S and then S going to Q. SQ and QS. So that means now for each vertices S and Q, we have 1, 2, 3. 3 going in and 1 degree going out. So we left another 1 degree going out and another 1 degree going in. Because here we already have 3. So we need another 1. 1 going out, 1 going in, 1 going out, 1 going in. So how are we going to do that? Alright, so when we have 1 out, 1 in, that means we have to do loop and loop. Because we know that for a loop, it's go out from the point and then coming back to the point. Going out to the point, coming into the point. So we have 1 out, 1 in. So finally, we already get the answer for the drawing of this directed graph. Okay, so another examples, let's say this is also a correct answer, right? Just that it's different in the shapes. Okay, so let's see another example. So this example is a problem solving for directed weighted graph. Okay, as we can see here, the directed weighted graph shows the price of tickets and the travel times for some choices of flights of a private airline. Okay, so vertex S is the destination of flight from vertex P, vertex Q and vertex R are the transit airports. The transit time at each of the airports is 45 minutes. Okay, so always remember, if you have problem solving questions, always the first step that you have to do is take out all the information given. So the important information here is that vertex S is the destination from vertex P, meaning we have to start from P and at S. We cannot start from any other point. We have to start from P and the end should be at S. And then vertex Q and R are the transit airports. And another important thing here that is not written in the diagram. There is no information in the diagram, which is the transit time for each airport is 45 minutes. You don't have the information in the diagram, so you have to remember that, right? So either you want to highlight or you want to underline or just write down the information in the empty spaces in the exam paper. Okay, so now let's answer the first question. State the most economical route. Most economical route means the route with the least price. Okay, so as we can see here, okay, as using the laser, okay, as you can see here, we start from P. We want the least price. So the way that we can go from P to S is that either from P direct to S, or P going to R and then S, or P going to Q, R and S, or P going to Q and then S. Okay, so if P go directly to S, we already know the price will be 200, so no need for calculation. So let's say I start with P going to R, going to S, P going to R, going to S. Okay, so the price will be 130 and then plus 65. So the answer will be 195, which is lesser than P going to S. Okay, so now we try to do another way, which is from P going to Q. Okay, so from Q is either you go to R and then S, or you directly go to S. But you can see here, if you go from Q to R and S, the price will be 45 plus 65, which is 110, lesser than 115. So we don't need to compare with QS. So the better, the more economical route is P going to Q, going to R, and going to S. So the price will be 50 plus 45 plus 65. So the answer will be 160, in which we can see that this is the least price for the route, and therefore the answer for most economical route is PQRS. Okay, hopefully you can understand that. Then we go to the next question, the route that takes the shortest time. So now we compare the time taken. Alright, so for this one, don't forget that we have transit time for airport R and airport Q. So for P going to S, there is no transit, so it is automatic 3 hours. Okay, so let's say I would like to do PRS, P going to R, going to S. So it will be 1.5 plus 1.1, which is 2.6. Oh, why I have 0.75 here? Yes, as I told you just now, don't forget the transit time, 45 minutes. Here is hour, here is minute. So we have to change into the same unit. So I change 45 minutes into hour, which is 0.75. So 1.5 plus 1.1, which is 2.6, plus 0.75, the answer will be 3.35 hours, which is longer than P directly go to S. Okay, so now I compared with PQ. Alright, going from P going to Q. So instead of you go to R and then you have another transit time and then you go to S, so the better way is going P, Q and S. So the answer will be 1 hour plus 1.4 plus, don't forget the transit time, as I already told you just now. So the total time taken will be 3.15. So what's the answer for question 2? Yes, for question 2, PS is 3 hours. Therefore, the route that takes the shortest time will be P2S. And so, what we have already learned in this video, the first thing, we compare and contrast between directed and undirected graph. And then we compare and contrast between weighted and unweighted graph. And then we draw directed graphs based on the given information. And the last one, which we just already did just now, which we solve problems involving weighted graphs. So stay tuned and don't forget, we still have many things to learn in this topic in the next video. Thank you. Assalamualaikum.